Let's see now the other method for assemblies, top-down. What does top-down mean? We build up each new component directly in the assembly file using geometric elements and parts already present as references, and make it become an external reference part or local component if we don't need it. We don't need to use it in other assemblies. It's another approach. In actual situations, we use both bottom-up and top-down because some parts may have already been created and we can insert them, while we must create other ones from scratch and save them. In the meanwhile, to show the parts we are interested in, we hit the head and rod and cancel the pin to create a similar one that will make a next reference, and move the work plane to one of the two faces. F8 from keyboard or the related arrow for top view being placed on the work plane in this case, and setting the color to red to distinguish it, we insert a rectangle with the related command, center and sizes, that will be both for X and Y, 55 by 55, and we place it at the center, this way creating a profile. Then, by the linear solid command, we create a sweep solid starting from the profile just defined. We have rotated for a better view, setting depth, for instance, to 6 millimeters, OK, and we build again little by little the previous part device pin. We rotate our object to easily insert the pin, enlarge the area, shaft command, and we place the shaft on the internal face that we are going to select. Then we reset the point. We want it to be at the center of the hole. OK. As diameter, we can use the adaptive measure. We state the diameter must be equal to the diameter of the hole that we are going to indicate. As for length, we can stretch directly the pin by dragging the dot or enter a specific value, and we confirm. We created a solid within the assembly. From this solid, now we create a part that we create as local component for the moment. We assume it's initially defined a local component. OK. Zoom entities to close up on the selected entities. Insert new component. And we give a name, Clevice Pin 2, for instance, to distinguish it from the previous one. Upon saving, we are asked what to do with references because we created the first solid laying the work plane on the Clevice face and the pin laid on the face of the first solid with links between the new object and Clevice that we can keep, not being able to use the part in other assemblies, or break, possibly using it in other assemblies once made as an X reference. We chose to break the links both on the first and second reference, and after this operation, we can even drag the local component out because it's not linked to Clevice. Well, we can make it an external reference, saving it as Clevice Pin 2. Now, let's see the component in local copy. Let's focus on the external reference part. It's an external reference used in this assembly, but we assume it's also used in other assemblies. We want to be able to make changes on this part in other assemblies, however, without modifying it until we are confident that the changes work fine. What do? Clicking on Clevice Pin 2, we edit its properties and set the part to local copy. Also, its icon has changed. In a way, we have frozen the part within the assembly. Now we save the assembly. as a C1, close it, and open the clevice pin 2 that we saved earlier. OK. And this is our external reference. On this external reference, let's make some changes. For instance, a hole on the front face, hole command, possibly a through hole. OK. We increase its diameter 20 and place the hole at the center, resetting the point. After making a change to the external reference, we save it directly by Save and Close. Let's start again, reloading the assembly we saved earlier. A C1. OK. Fit View. In the assembly, the part turns out to be still not modified because we had actually set it as a local copy. So, from the history tree, for instance, we can change the part properties, unchecking the local copy option, the local copy flag. OK. We are asked whether keeping the local copy or reloading the external reference. We reload the X reference so we can see the change. OK. Now we have selected the pin and cancelled it by the delete key and unhide the rod and head previously hidden. We see now how to use another command available for parts, derive and replace. In practice, this command allows the creation of a new component with different characteristics or features, starting from an existing part. Without the command, we should open a new model, insert the component in the model, make changes, and save it as external reference with a new name, while the command speeds operations. We apply the command, are asked to update some objects, OK, and to rebuild. We apply it again, and this time we confirm directly. The program asks whether leaving the name proposed with the suffix derived. We confirm, save it, and rebuild. Well, we set the component as current. Its name is now clevice head derived and no more clevice head. And add, for instance, a shaft, indicating the face on which the shaft, the pin, will be placed. OK. We also insert an edge fillet. OK. And enter another value for the radius, 0.2. In other terms, we make some changes to the part. Right-click, reset current component to go back to drawing level, model level, then always rebuild model. And let's now have a look at the part properties, that is, the properties associated to the part. For instance, clicking on the part itself, and the part number will be drv underscore that value. So this will be an external reference called clevice head derived. We reload the original part from which we started. Clevice head, always inserting the part. The operation reset the undo redo buffer and we confirm. We place it and see the properties of the original part this time. In the derived one, a new part with the prefix drv in the part number and the starting data had been created, keeping all the other data. This way, we created an external reference similar to the previous one with a single command, so we close without saving changes on the assembly and parts.